Today, let's fully understand standard deviation, which is very important in quality control. Hi, this is Magnegami, Lean Sigma Black Belt. One of my viewers sent me an email asking, can you make videos regarding Sigma value and examples of its calculations? Thank you, Rehan, for the request. We often talk about Six Sigma, but do we really understand Sigma? Sigma means standard deviation in statistics. So does Six Sigma mean 6 times the standard deviation? Today we'll focus on studying Sigma. Let's say that we measured 5 parts lengths as samples from your production line yesterday and today. What can we do to compare yesterday's and today's results? You would calculate and compare their averages first. Add all the data values and divide by the number of data. One little issue happened here. Even though the measured data are totally different, the averages of yesterday and today were exactly the same. Here is that situation on a chart. Today's data seems to have more variation. The numerical value of this variation is standard deviation. In Lean Sigma, it's fundamental to minimize variations and keep the quality consistent. Therefore, this standard deviation is very important. Well, how can we calculate this variation? The first thing is to add all the subtractions from each number to the average. But those subtractions are plus and minus. Their total will always be 0. Unfortunately, this is not useful. The subtraction from the average is called deviation, and there are 2 ways to make the deviation always positive. One is to use the absolute values of those deviations, which are each number's distance from their average, add them all and divide it by the number of the data. The other way is to square the deviation, which will always be positive. The value after adding them all and dividing the total by the number of the data is called variance, which is often used in statistics. I will not go into detail at this time, but since using variance made more sense, that has been adapted in statistics. Yesterday's variance was 0.006 and today was 0.034. But since variance was squared, its unit measure has changed. This time it has changed from centimeter to square centimeter. Therefore, we want to take the square root of the variance and change the unit measure back to centimeter, and this is standard deviation. Yesterday's standard deviation was 0.08 centimeter and today's was 0.185 centimeter, so it was numerically clarified that we had a bigger variation today. Do you understand the concept of standard deviation well? If so, let's have Excel to the rest of the calculations. In Excel, type equal STDEV, which stands for standard deviation. Then you'll see there are several standard deviation functions. If you are using Excel 2010 or newer, use the stdev.p function or the stdev.s function. With an earlier version, use the stdevp or stdev. The last digit p of the standard deviation point p function stands for population, and here it also says based on the entire population. The other one, the standard deviation point s function, the s stands for sample, and here it says based on a sample. These two differences also make standard deviation difficult. This time we have 5 data each day, but in practice we would make a lot of parts. For example, let's say you make 100 parts every day. You measure all parts lengths accurately and calculate the standard deviation. It's really accurate. We call that 100% inspection, but it takes time and cost. Therefore, we do sampling inspection, in which we randomly take samples and consider them to reflect their population. Standard deviation point S will be used in this case, and standard deviation point P will be used with 100% inspection. By the way, using the standard deviation point P function got the same result as the first calculation. With the standard deviation point S function, yesterday's result was 0.089 and today's was 0.207, which means both the variations show a slight increase. With this function, when calculating variance, the total of squared deviations is divided by the number of data minus 1, instead of by just the number of data. Since it divides by a smaller number, the result will be a little bigger. Meanwhile, it's easy to imagine that since the population is much bigger than its samples, the population's variation is larger than the sample one. Although there are few statistical reasons, basically past-wise people decided that when calculating standard deviation from samples, we should use the number of data minus 1. In summary, remember to use standard deviation point S with samples unless it's for 100% inspections. At last, we can talk about the initial question regarding sigma value. For example, today's data's 3 sigma is 3 times standard deviation, which is 0.621 centimeter. But when asked what the 3 sigma value of this process is, it's the average plus minus 3 sigma equals 8.56 plus minus 0.621, which is between 7.939 and 9.181. This is generally used as the upper and lower control limits when writing a control chart. By the way, the name Six Sigma that Motorola developed comes from the aim of Six Sigma level quality. However, its concept is quite different from the above-mentioned Sigma value. The Six Sigma value is the average plus minus 6 sigma, so it's easier to aim between 7.318 to 9.802 centimeter rather than aiming at 3 sigma value. Some people may get confused by that. The original meaning of Six Sigma is to improve your process with enough sigma, which is standard deviation, to reach 6 for the z-score, which is another measurement in statistics. The level in which it's achieved is only 3.4 defects per 1 million pieces, which is well known. Therefore, it's nothing to do with 6 times sigma. Does this make sense? Today, we discussed various things about sigma and standard deviation, which are very important in quality control. Thank you very much for viewing. Please click the subscribe button. Also, click and watch my other related videos. Thanks.